Okay, introductions to scale drawings. The first thing I want you to understand is that there are scale drawings, which are two-dimensional and flat, and then there are scale models, which we'll talk about more later, that takes it from a small to a big three-dimensional item. So first we're going to focus on how do we do scale factors. I'm going to get my correct materials for working. And this one says enlarge the shapes using the scale factor 1 to 2. So I see that this is 2 squares. I now have to make that 2 squares 4 squares. 1, 2, 3, 4. And this is 1, 2, 3. So it's 3 squares. I'm going to make it twice as big. So it needs 6 squares. 1, 2, 3, 4, 5, 6. And I'm going to finish drawing it. You can color it in with your pencil. You can make it beautiful, whatever you want to do. But making a scale drawing is just making something bigger or making something smaller based upon the scale factor. So we're going to do another one, hopefully. Okay. There should be a star on your paper. It's a little bit more complicated, so I have to think about this, okay? Got a dot here, a dot here. Those dots are 2 apart. They need to be 4 apart. Okay, now I need to think about this shape. That's 1. It needs to be times 2. So I'm thinking about where all these points are. Okay, now this line is 1. So I'm going to do 1 times 2. And this line goes across 1 square. It needs to go across 2 squares because it's times 2. So that would mean it goes like this. I'm going to do the same thing here. It goes across 1 square. Going to be times 2 squares. See my 2 squares? 1 little square, 2 little squares. Okay. That 1 turns into 2. Okay. This 1 turns into 2. 1 square turns into crossing 2 squares. 1 square turns into crossing 2 squares. 1 turns into going over 2 squares. 1 turns into crossing 2 squares. 1 turns into going over 2 squares. So there we go. That is how you do these 2 shapes. That is how you use the scale factor to get larger. If you need to pause to make it work better, please do so. Then, cross our fingers that my computer lets me. Yeah, it did. This one is a scale factor of 3 to 1. So instead of changing it times 2, it's going to be times 3. So my line of 3 turns into 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Whew. Yeah, interesting. That's what it wants, right? I want to make sure. Oh, it says reduce. Hold on. Miss Began, reduce. You see that? Reduce. So Miss Began made a mistake. We're not supposed to do that. So instead of making bigger, we're going to make smaller. So this 3 divided by 1 turns into 1. So that turns into 1. This 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 9 divided by 3 turns into 3. 1, 2, 3. This 1, 2, 3, 4, 5, 6, 6 divided by 3 turns into 2. This 1, 2, 3, 4, 5, 6. 6 divided by 3 turns into 2. 1, 2, 3. 3 divided by 3 turns into 1. And to double check, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 divided by 3 turns into 3. So my reduced shape shrunk. So scale factors can be bigger, scale factors can be smaller. That is this answer. Push pause if you need to, but you make sure that you have those answers. Whoa. Wait patiently. Okay, let's see if I can get this computer to move. There we go. We're still dealing with that smaller scale factor, so I'm going to count. That's 1, 2, 3. 3 divided by 3 equals 1. This is 3. 1, 2, 3. 3 divided by 3 is 1. This is 1, 2, 3, 4, 5, 6. 6 divided by 3 is 2. This is 3. Scale factor reduction of 3 becomes 1. I think we're getting the pattern. This is 6. Reduced by 3 is 2. This is 3. Reduced by 3 is 1. This is 3. Reduced by 3 is 1. 3 reduced by 3 is 1. 3 reduced by 3 is 1. And I think I can figure out the pattern. So that is introduction. We will be doing more with this and making it make sense like mathematically, but you're seeing that scale will be multiplying and dividing, and there's a couple of different ways to do it, but this is the introduction so that we can start having a visual understanding of what scale drawings and scale models are. They are going to make something bigger or make something smaller. In science, that's used when you look through a microscope, and in social studies, that's when you are looking at a map. Indiana is not this tiny on a map, so you need to think about these are used in real world. They are also used in construction when you have to look at what is to be constructed. So these are things that you will be using in real life.